Since the start of the Industrial Revolution, the primary goal of the global workforce has been speed and scale. We spent 2 centuries training humans to operate as highly tuned efficiency machines, but that model is now obsolete. Artificial intelligence processes and scales output at a volume that human biology simply cannot match. To understand what is actually happening to knowledge work, you have to break artificial intelligence down into 3 distinct capabilities. Classifiers process data to recognize patterns. Optimizers manage logistics to find the most efficient pathways. And generative AI synthesizes existing data to create entirely novel text, images, and code. What unites all 3 systems is their processing velocity and their complete lack of doubt. They execute complex analytical tasks in milliseconds, without the hesitation or cognitive friction inherent to human decision-making. If your professional value relies solely on executing tasks faster than the person next to you, you are competing in a race you will lose. To survive this transition, organizations and individuals must abandon the efficiency machine mindset and rebuild themselves as innovation engines. This requires a structural rebuild across 3 distinct layers. At the base, the macro-scale institutional systems. In the middle, the meso-scale pedagogical engine. And at the top, the micro-scale individual skill stack. You cannot survive this technological shift by simply purchasing a software subscription. Meaningful integration is a structural engineering problem. You have to solve it at the macro, meso, and micro levels simultaneously. At the macro level, AI integration is bottlenecked by physical infrastructure. Before an institution can deploy strategic automation, it has to modernize its data centers and untangle decades of legacy silo data. You cannot feed an AI engine with disorganized information. Once the data is structured, the organizational chart has to follow. The industrial model of top-down command and control management breaks when innovation can originate from any node in the network. Enterprises must shift to a decentralized structure, leading by design to allow ideas to flow organically from the bottom up and the middle out. This requires dismantling rigid functional silos. Marketing, sales, and engineering can no longer operate in isolation. Personnel must be mapped by their dynamic capabilities and adaptable skills, rather than constrained by static job titles. Management metrics have to reflect this change. Tracking hours logged or standard tasks completed is useless when an algorithm can generate the same output instantly. KPIs must shift toward human capability development, measuring how effectively managers coach their teams to think adaptively and solve complex problems. When institutional friction is removed, the results are immediate. At the university level, administrators are already deploying AI to run complex research proposals against dense federal and state compliance frameworks before a human ever reviews them, saving hundreds of hours of administrative bottleneck. If you try to bolt generative AI onto an industrial-era organizational chart, the friction of the legacy system will neutralize the speed of the technology, rendering the entire investment effectively useless. This line graph from a Central China Normal University study plots time against cognitive ability, illustrating the AI capability gap. It shows that when students use AI, the cognitive abilities of strong students accelerate exponentially, while the abilities of weaker students abruptly flatline. Passive interaction with AI widens inequality. If you use the tool to think for you, your cognitive skills atrophy. To actually leverage these systems, humans must possess deep, fundamental domain knowledge to properly evaluate and guide the output. In one recent case, a team of engineers attempted to train an AI to detect cervical cancer. Because they lacked medical fundamentals, they optimized the system to flag every single suspicious cell, creating a massive false positive rate that overwhelmed physicians. They built a highly efficient solution to the wrong diagnostic problem. Avoiding this requires an active, agentic learning workflow. Step 1 is ingesting macro knowledge systematically. This involves feeding raw data, textbooks, and documentation into broad research tools like Notebookin to establish a baseline understanding of a new domain. Step 2 is synthesizing that research. By taking the outputs from your broad research and running them through high-context models like Claude, you can prompt the AI to design a bespoke, customized curriculum tailored exactly to your existing knowledge base. Steps 3 and 4 anchor that learning in reality. This means linking your progress to quantifiable tracking applications, like custom desktop widgets, and storing your notes in a localized knowledge graph to build a permanent, searchable memory system. The professional landscape is dividing. The future belongs exclusively to active learners who orchestrate AI systems to build their own knowledge, leaving behind passive users who rely on the machine to do the thinking. This chart outlines the exact skill stack required to remain competitive. The first tier establishes the baseline requirement for any professional, formulating a personal thesis on how AI impacts your specific industry, mastering structured prompting frameworks, and adopting a core model for daily use. To signal this foundational competence to the labor market, targeted certifications carry heavy weight. Programs like the Amazon Certified AI Practitioner or Wharton's AI for Business module prove you understand how to deploy these tools to increase productivity and profit without needing to write the code yourself. Moving into technical execution requires an intermediate grasp of programming languages like Python. The labor market demands validation for these skills through specialized credentials, specifically the IBM AI Developer Professional Certificate and Microsoft's AI and Machine Learning Engineering programs. For those overseeing the actual deployment of these tools across enterprise teams, rigorous niche credentials like the PMI AI Project Management certification demonstrate the ability to manage complex AI product rollouts and data security needs. Standard college degrees do not yet reflect the realities of the 2026 labor market. Right now, hyper-targeted professional certifications are the most reliable signaling mechanism to prove you have adapted to the disruption. True leverage requires moving beyond the basic chat interface. The critical transition from basic to intermediate capability involves ditching single-prompt queries and executing multi-step agentic workflows, where the software pursues a broader goal by breaking it down into individual tasks. How you deploy these agents depends on your security constraints. Running local, open-source models like Llama directly on your hardware ensures total data privacy. Utilizing closed-source commercial systems offers massive computing power, but requires sending proprietary data to a third-party server. This diagram illustrates the advanced capability of agentic engineering. By using Model Context Protocols, or MCPs, developers can build commercial pipelines that securely link a central language model directly to third-party apps and custom databases, allowing the agent to read and write data autonomously. When paired with AI coding frameworks like Bolt or Cursor, a single developer can construct and deploy functional, production-grade web applications at 10 times the standard development speed. Knowing how to string together automated multi-agent systems is the ultimate technical moat. It marks the exact boundary between professionals who simply consume artificial intelligence and those who actually command it. This acceleration carries a massive systemic risk. A handful of tech corporations currently control the most powerful generative models on Earth. Their business model requires strip mining human data and expertise to train their systems, concentrating the profits into an incredibly small geographic area. Because raw efficiency and standard programming are rapidly becoming heavily commoditized, trying to outcompute the machine is useless. Going forward, human professional value centralizes entirely around a concept called onliness. Onliness is the precise combination of traits that an algorithm cannot replicate. It is the synthesis of your lived experience, your deep domain expertise, and your ability to exercise the core human muscles of curiosity and creativity to identify problems the machine doesn't even know exist. By mastering the macro, meso, and micro layers of AI architecture, you stop being a passive data point. You force the technology to function as a collaborative amplifier, using its speed to execute your ideas rather than allowing its scale to replace your labor. The window to proactively dictate our relationship with this technology is closing. You can either learn to engineer the system or prepare to be managed by it.